So, OK, should we start? Yeah. OK, good morning, everyone. My name is Daniel Mellado, and I'm a core reviewer and deputy for the rookie cycle for Kuryr. Here today just to give you a brief update on the work that we have been doing so far in the rookie cycle and what we have done in Queens. I have had the pleasure of having today with me Maisa Macedo, which has been working with us this past cycle as an intern, now hired as an employee. Let me go ahead. So first of all, for all of you who are here present, is there anyone who doesn't know who Kuryr is? Raise your hand. OK, this makes things much easier. Just in case, Kuryr is a project which aims to be a bridge in networking in between OpenStack VMs and Kubernetes/containers. So that would allow you to do mixed workloads in between VMs and pods or containers, up to you, which makes things much easier when you are doing hybrid deployments, such as you would like to install Kubernetes on top on OpenStack and so forth. So overall, we support two different kinds of deployments. The first one is that we support side-by-side deployment. That means that we have Kubernetes on one side, OpenStack on the other one, and then we have we got Kuryr just watching the events that the pods are going as using the CNI plugin, and also we go and are watching the neutron events as a port is created and so forth. The second deployment tab is a nested one, and that makes things a little bit more interesting because that would allow you to have Kubernetes on top of an OpenStack VM. That would allow you to, well, we use the McMillan type to split the network type in between the pods inside the VM and so forth. So let's go ahead. We started this work in the Liberty cycle, and to be honest, we have been getting a lot of traction after that. Our main contributors as of now are Red Hat and Huawei, but we have been having contributors for quite a lot of different companies, such as Fujitsu, Intel, Cloud99, Samsung, NEC, Cisco, and so forth, and of course, a lot of individual contributors as well. So let me give you a brief overview of, put it here, a brief overview of the work that we have been doing for Queens. So first of all, we have been working a lot on scalability. One of the things that we were interested the most on this cycle is to greatly increase the pod per second head count that we could handle. So this has been greatly employed. Also, basically, when we were creating pods, we saw that what was blocking us was Neutron, as Neutron originally was meant to create ports for VM and not for pods. And the pods, of course, scale at a much higher rate. So for instance, Neutron was fine if we were asking Neutron to create, I don't know, 100 ports. But if we asked Neutron to create 1,000 ports, then things started going a little bit haywire. So we achieved a new feature, which is called port pools. It's basically that we pre-create a pool of already pre-created ports, and we fetch them on the fly when creating pods. So that can be configured to be as small or as big as you would like to. And it would work a little bit in the same way as the node pool works on the OpenStack infra. So if you start creating pods, it will just create this, fetch them for the port pool, and so on, and it will be generated. So we also were working on CNI daemon, which basically means that we have a daemon running on, so it interacts and caches all the CNI transactions. We have been adding OpenShift compatibility. One of the things that we did good, I think, is that we created the Tempest plugin, because previously, to Queens, we only had functional testing. That means it was more or less OK, but as you know, that real testing makes this even better. So we integrated the Python client, the Python Kubernetes client into our Tempest plugin. And we inherited from the Neutron-based class as a manager in Tempest. So now we are able to do tests in our gates, such as create a pod, create a VM, wait for them to be ready, and pick each other, so we are sure that it's OK. Also, we started creating packaging, so they are available on the RDO distribution. So you can, if you happen to have RDO around, you can just do yum -y install Python Kuryr and Python Kuryr Tempest test, and you would get those. Also, we were working on the initial draft for the controller health check, and also removed completely the need for Neutron LBAS version 2, and now we speak directly to Octavia, which has been a great improvement. Thanks, Michael. Because basically, we were having a dependency on that, especially for our CI, which made us install Neutron LBAS v2 all the time, which was an overhead that we didn't really need to do that. Also, we containerized almost everything and are starting to work on the kubectl plugin. And no, Maisa is going to go ahead and explain what we plan to tip and rock.
OK, so for the rock cycle, we aim to give to add health checks for the CNI, and also to add the VIF choice, so the multi-VIF for the CNI daemon. And also we are adding Kuryr in containers, deploying Kuryr in containers. And also the network policy support, which we are doing it by leveraging the security groups resource from Neutron. And we are adding Ingress Controller, which is going to update the layer 7 rules, and extending the test coverage on the Tempest plugin, and also enhancements on the upstream gates by adding multi-node testing for other SDNs, such as OVN and ODL and Dragonflow, and also have availability for Kuryr-Controller. And also, we have a work in progress for a kubectl plugin for pool management, which is just helping the user for like scale the ports in the pools and delete them and listing and so on. And also, since OpenShift is moving from having a subnet per node to having a subnet per namespace, we are adding this to Kuryr as well. So as I mentioned, Kuryr can be deployed in containers. So basically, it's the same way that other SDNs works in Kubernetes. So we have a controller modeled as a deployment and a daemon modeled as a daemon set. And we have a tool that you can use to generate these resources and then apply it to your cluster. So by having Kuryr running containers, it is needed that we give Kubernetes tools so it can check and recreate in case of any failures. And we provide this by means of readiness and liveness checks. So basically, we check if we can watch the Kubernetes API, talk to Neutron, and authenticate to Keystone, and also if the pools are ready with the ports. If the ports are loaded into the pools when it's required. And for the controller components, we analyze it if the handlers and watcher are healthy enough. And for the CNI, we provide to Kubernetes if the NetAdmin capabilities are present, and if it can't watch the Kubernetes API as well, and the IPDB, which is database, is in working order, and the quantity of CNI defilers have not reached a maximum amount, which is configurable, and also if no memory leaks is presented, and if the binding drivers are OK. So we are adding a new service to Kuryr, which is the Kuryr daemon. So basically, the CNI, how it previously works in Kuryr, every time that a pod is scheduled, it is going to create a new process that is going to connect to Kubernetes API. So now, by having the daemon, we are going to have a long daemon process running, which is going to make only one connection to the Kubernetes API. And by doing this, this is much more scalable. And so no more requests having to go all the way to Kubernetes API. So only one will be presented. And the CNI daemon feature if you deploying without the CNI daemon, is going to be deprecated on the rock cycle. So.
Yep. So another thing, another feature that we are working on, which was initially started from for some folks from Huawei, but we have taken it over, is, as Maisa said, we are also allowing translation from Kubernetes network policy groups. There's another session which would take these under deep detail, because it's at 1 p.m. But basically, to have you an overview, what we would like is to have like network policy groups to be mapped to security groups in OpenStack, and basically the label from the network policies would be mapped to 1 to n security groups with 1 to n security groups rule. One of the things that we think it might happen too is that, as well as with Neutron it happened with the ports, we might need to create another feature which would be a security group port pool, because this, as it is now, would create a really lot of security groups that this might be straining the Neutron API. So even so, there's a blueprint in Neutron for the Rocky cycle, which is basically meant to avoid this kind of stuff to happen. We have also been working on allowing Ingress Controller translation, where we will collaborate again on the Octavia folks. Thanks again, guys. Basically, we would scale, we would allow translation from an Ingress controller in Kubernetes to a router or a load balancer on layer 7, in using Octavia, of course, and OpenStack. For this, we were thinking about two approaches. The first one would be to just use Octavia, and the other one, depending on how much we would like this to scale, we're thinking about using OV and LBAS up to layer 4 for east-west traffic, and then Octavia for layer 7. But that's still a work in progress. Just let me go, you go next. Yeah. So this is an overview of the feature. Basically, we'll be having Octavia acting as a layer 7 routing engine, and we'll be having also the DNS server, which fetches all external traffic and routes to Octavia, which afterwards boot up whatever needed to the pods. Okay, so what again? As you might know, also in the Rocky cycle, we have been finishing with the Solve 3 migration. I guess we were one of the first projects who made this migration successfully. So now you can just do inheriting in terms of jobs from Sol. So basically, we are inheriting from 2 jobs. We have, which is the DevStack one and the Tempest one, and that allows us to have also parent jobs and child jobs. So we start having basically base jobs using both Octavia and LBAS version 2. LBAS version 2 will be deprecated in this Rocky cycle, so we will get rid of them. We are using a daemon and containerized daemon Kuryr jobs. Will be probably just deprecating the demonized ones this cycle. So one of the cool things that Solve 3 allows you is, as Maisa was saying before, to have multi-node testing, especially in networking projects. If you go and test everything upstream in one single node, there's no way you could really detect networking failures, because everything will be just localhost. So now with this, we will be able to track those in a much efficient way. And also one of the things, and I guess that's a real common theme for all the projects, is that we were limited by the upstream CI in terms of the amount of memory that you would have in your node. As of now, the max that the upstream CI is giving you is 8 gigs. So what would happen if, you can just imagine the amount of memory that we are going, if we need to go install DevStack, we need to go and install a Hypercube, which would mean Kubernetes. Now we go and deploy a service, that service would go and deploy one VM using Octavia, and then afterwards we would need to go and deploy more VMs to do the actual testing. That means a memory eating thing that won't be possible with just one single node. So this would make things much, much easier for the cycle. Okay, so beyond Rocky, there are 3 main features that we think we will be working on. Of course, there's still the Denver PTG will be coming over, where we will revisit this. But basically, we are interested and have already quite a few patches on DPDK and SRIV support. Of course, the SRW support won't be really possible without a third-party CI. We are basically collaborating with Samsung in order to boot up third-party CI, which would have IOV capabilities. But we are quite advanced in the DPDK feature. We also do plan to check multi-beef plugin driver, just a little bit about how Multus works, where you could have different beef drivers using different plugins. And HTL is something that we do plan to take a look to. So just let me get you an overview about the current state on DPDK. So basically, this is the current status. I mean, we have a blueprint for this, which is being worked by the Intel guys, which is in working status, but just need a little bit of draft. In this case, basically, the Intel plugin provides Dataplane networking to nested Kubernetes pods. Here we are speaking about the nested use case. Remember, where we are having the pods in a nested environment, and it'll basically the Kuryr CNI will bind the virtual port to a DPDK driver, and well, it will work as basically the same thing as with another drivers in Kuryr, but just implementing this DPDK stuff. Well, here's a quick overview. Here's how, as we were saying, we have this Virtual which would implement DPDK. But as we are a little bit short on time, I would ask you kindly that if you're interested in this, please ping me or ping us offline. So I guess, so if you are interested in giving us feedback, just tell us how bad we are, or just implement a new feature. We are hosting a weekly IRC meeting on OpenStack Kuryr and OpenStack Meeting 4. We are also quite active on the mailing list, and you can feel free to report any bugs or blueprints you might want to work into, as we are, of course, always needing help. As I said, go ahead and don't hesitate to ask us. Thank you. So any comments or questions?
For DPDK support, do you need virtual IOMMU?
Sorry?
IOMMU in guest? I mean, do you have any requirement for hypervisor technology?
Not really. Not really. I mean, the way that the Intel folks are implementing this technology is that it would be hypervisor agnostic. So that would just work fine, theoretically, on any hypervisor. In any case, feel free to come over and we'll speak about this offline. Anyone else?
So when you mentioned the containerization of the Kuryr services and the CNID, I was kind of under the impression that some of that work was landed already. So is that more work to be done in Rocky, or is it?
Yeah. So we'll further improve that. But most of the job was already being done in Queens. Yeah. Go ahead, Mace.
No, I mean, we are, for future work, we are planning to move all related VIF to the CNI. So we introduce high availability to it.
Go ahead.
Well, multiple network feature, I don't see in your presentation. So what's your plan? I see there's a blueprint in the multi-pack.
For what? Sorry, I didn't get it.
Multi-network.
Multi-network.
Yeah, I mean, there's a blueprint on that we do plan to work into that, but it's in a work in progress status as of now. So you can just track its status there. We do plan to update it. Okay. So then, thanks everybody for attending, and good summit.